Okay, so we have to be able to add and subtract these. So let's have a little look at my first example over here, where they have, when fractions have the same denominator. This one, I hope we're all on the same page that would give 5 sevenths. Very good. So if they have the same denominator, they can be combined. We do not add the denominators. The denominator stays the same. If I have 2 of something and 3 of something, I end up with 5 of something. And the something here is sevenths of something. So just add. As soon as I have the same denominator, I can go ahead and add or subtract. So if that was 3 over 7 minus 2 over 7, then I would say, right, my answer is over 7 again, and I just do 3 minus 2 to give 1. So it's very straightforward if I have the same denominator. If I do not have the same denominators, such as in my second question, I have a quarter plus 1/6, I got to think about using equivalent fractions. So fractions that have the same value as 1/4, but are more useful to me. So it's more useful here if I have them both with the same denominator, so I can add them. So it's more useful to write both these fractions over a common denominator. What would be a common number that both 4 and 6 divide into? Alex? 12. That is the lowest one as well. That's great. So they both can be written as a fraction out of 12 because they both divide into 12. 6 times 2 gives 12. So I have to multiply the top as well to form an equivalent fraction. Remember, if I want to get an equivalent fraction to 1/6, I just can multiply the numerator and denominator by the same number. So it could be 5, for example. And that would give 5 over 30. That is equivalent. And I can multiply it by 12 if I want. And that would be 12 over, what's 12 times 6?
72.
72, very good. And that is also equivalent. Okay, so I can get a bunch of equivalent fractions, whichever one suits me. Now in this case, 1/6 can be written as 2/12. That suits me. 4 needs to be multiplied by 3 to get to 12, so the numerator must also be multiplied by 3, and I get 3/12. Now, because I have the same denominator, I can add, and I get 5/12. 3 of something plus 2 of something is 5 of something. Very good. Next, we go on to example 3. So what happens if they are mixed numbers like we were just talking about? So if I have 1½ plus, I think that one says 2 2/3, is it? Yes, 2 2/3. Okay, there's 2 ways I can go about this. I can think about it as I will add the whole numbers and add the fractions separately. Or I can think about, I'll change them to what? No, they are mixed. Improper. I'll change them to improper. For this example, I'm going to change them to improper because if I use improper, it works for both addition and subtraction. Mixed numbers don't work great with subtraction. They're perfectly fine with addition because 1 plus 2 will give 3, and then I can add the bits, the fractional bits, and I'll get the answer. But I'm going to use improper here, which means I have to remember how to change to improper fractions. What's this one going to be?
3.
2 times 1 is 2. Add 1 to the top is 3. So 2 times 1 is 2. Add it to the 1 on top, that's 3. Still 3 over 2. 3 times 2 gives 6. Add it to the top gives 8 over 3. And now I think about a common denominator. What's my best option here? 6, yes, because 2 and 3 both divide into 6. Right, so I must multiply this one by 3 to get to 6. So the top's multiplied by 3, which is 9. This one has to be doubled to get to 6, so the top is doubled, 16. And now we have the same denominator, so I'm ready to do my answer, which is 25. 25 over 6. Is it better to leave your answer as an improper fraction or a mixed number? Yeah, usually a mixed number is considered fully simplified. So what is this as a mixed number?
4, 1.
Yes. 4 with a remainder 1. 6 fits into 25 4 times with a remainder of 1. So that's 4 with a remainder of 1 out of 6. Very good. We're going to do one final example with subtraction and a mixed number. Let's get to that. Okay, mixed number subtraction. So I've example number 4 here. I have 3 1/4 minus 1 2/3. Step 1, improper fractions. So I'll change them to improper fractions. 3 times 4 gives 12, add to the top, I get 13 fourths. That's the same number, just written as improper. 1 times 3 gives 3, added to the top, I get 3 plus 2 is 5 thirds. If you ever cannot think of a denominator, what's a trick I can always use? Yeah, the cross method. I can just multiply these two together and that will always give me a denominator. And if I do that, I can just multiply in diagonals to get the numerators. So I'll do that this time. 4 times 3 gives 12. That means both denominators are 12, 4 times 3. And then this will multiply by this to give 39. And this will multiply by this, 20. The subtraction is still there. And now what's my answer? 19 over 12, which I can convert to 1 and 7/12. Very good. Okay. All right. So that's our method. What's our time looking like?